All right, so in this next video in 1.6, we're going to take a look at two more functions, and we are going to use three different ways to show that these two functions are inverses of each other. Okay, so algebraically, graphically, and numerically, basically the summary of the notes that I gave you will be illustrated in this example. Okay, so for part A, how do I show that these two functions are inverses of each other? Again, you use the definition. Okay, you don't get y by itself and switch the x and y. Switch the x and y and get y by itself. You don't do that. That's if you want to find the inverse. But to verify that these two are inverses, you have to show, just like I did in example 1, except this time we call it f and g. F of g of x is equal to x, and g of f of x is equal to x. Okay, so that's the definition. That's how you verify that these are inverses of each other. So let's do the function composition for f of g of x. F of 4x plus 1 into my function. F of g of x into my function would be 4x plus 1 minus 1 over 4. These guys are going to cancel out. You're left with 4x over 4. Cancel. F of g of x is equal to x. That gives you the identity function. And then g of f of x. G of f of x would look something like this. So I plug this into my g function. X minus 1 over 4, and then add 1. Okay, so these 4s will cancel out. You have x minus 1 plus 1, and that also equals x. Okay, so there's part A. And then part B, graphically, let's just sketch the two lines here. So I have my f of x, which is, essentially 1/4 x, right? Minus 1/4. And over here, my other g of x right here is 4x plus 1. So you can make a table of values. So for this guy right here, I already know that my y-intercept is just 0, 1, right? You could just do a rise over run, but let's make, maybe let's plot one more point. If we plot 1, we're going to get 5. Okay, so for for f, remember what I said was true about the coordinates, right? 0, 1 actually becomes 1, 0. And 1, 5 actually becomes 5, 1. Okay, so if you plug in x is 5 right here, 5/4 minus 1/4 is 4 or 4. These coordinates interchange. In fact, we'll call this B and C, okay? Because numerically, right, this is, you can see on the table that these coordinates interchange. You can plot one more point if you want, but there's my part C, okay? All right, so just graph it. And when we graph it, right, what must be true? It should look like that both of these graphs, right, are reflections over the line y equals x. So 1, 0 for my f function. There's my x-intercept. 5, 1, looks something like this, right? Okay, so there's my f. And then for g, right, I have the y-intercept at 0, 1, 1, 5. And roughly there is my g. Okay, so does this look like it's a reflection of the line y equals x? And it should look like it, right? So y is equal to x. There is my dash line, if you will. Okay, so we verified algebraically by using the definition. Part C, numerically, right, you could see on the table that the coordinates interchange. And then also along with that, once you have the table, right, you could just graph it, and you could see